Welcome back, everyone. In this lecture, we're going to finish off by going over the challenging problems. And we're going to start off with spy game. Now, spy game at first seems similar to the get33, except in this case, we want to write a function that takes in a list of integers and returns true if it contains 007 in order. And that actually doesn't mean in consecutive order. And we show that by the second example here. So this first example, you can see here has 007 or 007 in order, so it returns true. Now you'll also notice on the second one it has two zeros showing up before a 7, which also means true. So this 007 doesn't have to be consecutive, it can also work like this, 007. And here you can see we have 700, so that returns false. So let's see how we can actually approach this problem. We'll say spy game function, and it takes in some list of numbers, num. So right off the bat, we know we're going to have to go through each of these numbers and do some sort of check. So something that might be good is say for num in nums. And right now we can say pass just as a little placeholder while we think about this. I want to check if two zeros show up before a 7. So there's lots of ways we could do this, but one way is to set up a code list. And our code list is going to be 007 and then some extra string. So we'll have X there. And what we're going to do is we're going to go through every number in this list, and if we hit the first item in this list, we'll go ahead and just pop it off. So what I mean by this is if I say for num in numbers, if my current number is equal to the first item in code, what I will say is equal to the first item in code, so code at index 0, I'm going to take that code list and pop off that first item. So what does this actually mean? It means as I'm iterating through this list, I'm checking the number and saying, hey, is this number equal to the first number in this code list? So you can imagine for this first case, eventually I hit the 0 and I say, yes, I have a match, 0 and 0. So what I do is I pop off the index at 0. So that means I pop off this 0. So then the next iteration of code looks like this. We have 0, 7, and then some string, x. And then if I get another match, then I pop off again. So I will get 7, and then the string x. And then if I pop off one more time, meaning I matched 007 in consecutive order, then I'll just have a list of length 1. So notice here we have our length is equal to 1. And you could also just check if length is empty or something like that, but we'll do length equals to 1, just so it's easier to understand. So then here, I'll just return is the length of my code after running that for loop equal to 1. So let's walk through this one more time because the code is a little weird at first, but if we break down the logic, it'll make sense. I have this code list, and it has 007 and some extra string. And I'm going to go through every number in this list, and I'm going to check, is that number equal to code at index 0? If that's the case, then I'm going to pop off the first item in code. So it's first going to start off at 0. That means now code is equal to 07x. So I keep doing my for loop, and I check, hey, do I have this number equal to code at 0? So that's this 0 now. If that's true, then I pop it off, and now my code list looks like this, 7x. So I keep going around until I see that 7, and I say, hey, if 7 is equal to that first item in that code list, this 7 right here, then pop off that 7. And if I'm able to go through this entire for loop, and I finally, since it's a list of integers, I have a string here, and it's going to be a list of length 1, then if length of the code is equal to 1, then I know I had 007 or 007 in order. So we can check this out by running this. Let's grab some of these examples, run them. We get back true. Let's run the second one. We should also get back true. And let's run the third one, which should bring back false. Okay, so again, this one's a little more challenging because we had to use an outside data structure and use logic in order to figure out how best to find those consecutive numbers. There's tons of different ways you could have approached this one. Feel free to share your other methods in the Q&A forum. Okay, the next question was count primes, which was to write a function that returns the number of prime numbers that exists up to and including a given number. And by convention, we'll treat 0 and 1 as not prime. So how do we actually approach this? Well, we're going to start off by saying def count primes, and we pass in some number. So that's going to be the integer itself. Now since we're treating 0 and 1 as not prime, we might as well have a quick check for them. So I'm going to say if that number that the person inputted is less than 2, meaning it's 0 or 1, or it's a negative number, we'll just return 0. So this is our check for 0 or 1 input. Now, if we've not returned yet after this check, then we know we're dealing with a number that's 2 or greater. Now 2 itself is a prime number, and I want to make a list to keep track of prime numbers. So here's what I'm going to do, and this is kind of a clever trick, which is what makes this challenging. I will start off my list called primes with the number 2 in it. And then I'm going to set a variable x equal to 3. And what I'm going to do is I'm going to keep adding onto x until I hit the input number, and we'll check if x ends up being prime or not. So let me show you what I mean by that. So we already know that if we've gone past that if statement, then we're dealing with 2 or greater. And we have here a list. Let me zoom in just a little bit here. We have in a list to store our prime numbers. And then we have some sort of, we'll say x is some sort of counter that's going up to the input num. And we'll say while x is less than or equal to that input number, I'll say for y in range from 3 all the way up to that current number x, and then we'll take step size of 2. The reason we're taking step sizes of 2 here is because even numbers beyond 2, we already know those will not have a chance of being prime because they're even numbers. They're all going to be evenly divisible by 2. So what we're doing here is we have x, which is this counter. And then we're saying, okay, kind of a sub problem here. We need to check if x itself is prime. So x is going through every number up to the input number. And then here we need to check if x is prime. So we'll say for y in range from 3 to x in even steps, because we only want to check odd numbers there, if x mod y is equal to 0, then we know we don't have an even number there, or excuse me, we know we don't have a prime number there. So what we're going to do is add 2 to x, kind of add 2 to our count, and we'll break out of this for loop. So this for loop, all it does is this checks if x is prime, because it's going through every number in range 3 up to x. Remember, x is going then through every number up to the input number. So this is checking if x is prime. We say if that x number is ever evenly divisible by one of these numbers in its range, then we know it's not prime, and we're going to add a count 2 to kind of hop ahead past that even number, and then we'll break out of this for loop because we're done checking if x is prime. However, if we're able to successfully go through that entire for loop and we don't actually end up breaking out of it, then we have a prime number somewhere. So what we want to do is take that prime number and append it to our primes list. And this is what makes the problem challenging, is that you can use a for else statement. And this is something that's unique to Python. Note how my else is actually lined up with my for instead of with my if here. And that's because I have a break inside of my for. So what this else is saying here is if I went through this entire for loop and I never broke, then this else statement is going to execute. And again, this is something unique to Python, the for else. We haven't talked about it before, which is what kind of makes this a challenge bonus problem. So if that happens to be the case, meaning we checked and we never broke out of this, so x actually is prime, we're going to take our primes list and we'll append that x number to it. And then we jump ahead past that even number, so we'll say x is now equal to x plus equal to 2. And after this whole thing's done, we're going to print that list of primes, and then we'll return back what the question's actually asking, which is the length of how many prime numbers there are. So let me quickly go through the logic here one more time. We first check for 0 and 1 input by saying if number is less than 2, return 0. Then, since I know I'm dealing with a number of 2 or greater, I'm going to start off my count of my prime numbers with the number 2 in there. so I can start off with 3. And the bonus of starting off with 3 means I can use a step size of 2, and that's indicated here from range 3 x2, as well as when I'm adding 2 to my count of x, if I end up breaking out of one of these for loops or I trigger that else statement, because then I'm skipping along all those even numbers, which is why we have plus equals 2 here, and why we're taking a step of range 2 there. And then what we're doing is we're going through x all the way up to that number, going to check if that x is prime, and if it is prime, meaning we never broke out of this, we're going to append it to the prime list, and then add 2 to our count, and keep going through this while loop. Then we're going to print all our primes and return the length of primes. So we run this, and we say count, call count primes here on 100. We get back that list of primes, and we get back the number 25. Now there's a clever trick you can add to this, and the fact is that you actually don't need to check every single number up to x here. Instead, recall that you're actually already storing a list of primes here. So you could say is for y in, and instead of saying range 3x2, you could say for y in primes. So that makes use of those prime numbers you're collecting as you go along. So now it's saying for y in prime numbers, check if x mod one of these prime numbers is equal to 0. And that's how we can do another x is prime check there. Keep in mind, this has to do more with math, I believe, than coding. So if this is a struggle for you, don't worry about it too much. This is more of a challenge math problem than a challenge programming problem, I would say. Especially since this is a challenge problem, it's a bonus, and you're still not quite at the skill level where you can tackle 2 problems at the same time. One is a really hard programming problem, and the other one is a really hard math problem. So this is combining both of those, which is what makes it really challenging. If, however, you really like these sort of problems, what I would check out is the Euler project. That's EULER project. Then it has a ton of these types of math problems that can, in general, only be solved with coding. So definitely check out that website if you happen to really enjoy this one. If you are totally lost in this one because of this heavy math, don't worry about it. That's why it's a challenge problem. Okay, so that's it for these 2 challenge problems. We also had a just for fun problem. It wasn't really a real. It was just printing out functions that takes in a single letter. So I'll bring that over from the notebook itself. So this was a just for fun, and it's basically where you had to kind of invent a dictionary that would print out these letters. And because of that, we're only able to say A, B, C, D, E here as examples. Everything else you would have to kind of manually print out. But it's just an idea of how you could print out actual graphics using Python code. And we'll get an idea later on using your first milestone project so you can have graphics that you can interact with a user. That'll be for your tic-tac-toe board that'll be printing out later on. Okay, if you have any questions, feel free to post to the Q&A forums, but we'll see you at the next lecture.